welcome to True Projects. In this video, we are going to discuss about the project, which is an efficient computational risk prediction model of heart diseases based on dual stage stacked machine learning approaches. So, before getting into the execution, let us understand what is the project about. Do you know that heart disease is a big deal all around the world? It is actually one of the top reasons people pass away. One of the main types of heart disease is called as coronary heart disease, and it is very serious. But here is something you might not realize. Treating heart disease is super expensive. We're talking about the cost that could hit trillions of dollars by the year 2035. That's a lot of money, right? And that's a lot of cash that could be used for other important things. So, what can we do about it? Well, we need to find ways to treat and prevent heart disease without breaking the bank. That is where smart and cost effective strategies come in. By finding the ways to treat heart problems without costing a fortune, we can help saving lives and keep everyone healthier. So, in this project, we are going to develop an efficient system using machine learning to predict the risk of heart disease. By analyzing data on factors like age, blood pressure, and cholesterol levels, our goal is to create a reliable for healthcare professionals to intervene early and improvement patient outcomes. So, to predict this risk of heart disease, instead of relying on just one model, the author in the base paper, he has combined different algorithms, which is called as stacked ensemble approach and also stacked machine learning approach. And it is a dual stage approach. This helps making the predictions more accurate. Here, the author has combined random forest, extreme gradient boosting, and decision tree. These are combined in stacked ensemble method. It is just like putting together a team of experts to give you the best advice. And to make sure the models work their best, the models are fine tuned on the techniques like random search CV and grid search CV. Furthermore, to improve the performance, we have proposed a technique called voting classifier, which is an ensemble technique. And this method combines predictions from various models for more accurate outcomes. Here in the project, we have combined bagging classifier, random forest, and decision tree. By integrating this advanced ensemble technique, we aim to provide healthcare professionals with even more reliable risk prediction models for heart diseases. Moving on, here flow begins with exploring the data. So here we have imported heart disease data set. We have used two types of heart disease data sets. And then we pre-processed so that it makes easier to understand and prepare the data for analysis. Then we split the data into train and test. Train is for training the models, test is for evaluating all the models which we built. After we train, After we split the data into train and test, we train different models to predict the heart disease, and those models are XGB, random forest, decision tree, linear regression, support vector machine, and voting classifier. After training, we evaluated these models using metrics called accuracy, precision, recall, and F1 score. These metrics they help us in understanding the effectiveness of each model in classifying individuals into different risk categories accurately. And then we find the best setting that is best model for these models. So we found that voting classifier it has performed well. So we saved that and then we deployed it in the Flash based frontend, which is a web application. So to implement this project, we need software and hardware requirements. In software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Moving on, these are the algorithms which are built in the project. The first five algorithms are according to the base paper and they are built individually. That is, they are fine-tuned individually on random search CV as well as grid search CV. And the last model is our proposed model, which is voting classifier. It is the combination of bagging classifier, random forest, and decision tree. Along with our proposed model, we also built other models to compare how well the voting classifier is performing. So, what is this voting classifier? Voting classifier, it combines predictions from multiple individual models, including a bagging classifier with random forest and decision trees. Each model independently predicts the risk of heart disease based on various features and historical data. The voting classifier is then aggregates these predictions using methods like majority voting or weighted averaging to make a final decision about individuals' risk of heart disease. By harnessing the insights from diverse models such as bagging classifier, random forest, and decision tree, the voting classifier aims to enhance the accuracy and reliability of heart disease risk predictions. So now we will execute the project. To execute it, we have to open the code folder which contains source code files. So these are the source code files in the code folder. Let's understand each file. How will they be used in the project? So here we have two folders in which we have two separate data sets related to heart disease. In the project, we'll be training each algorithm individually on both the data sets. So in the first folder, we have heart disease data set related to Cleveland and Hungary. So I'm opening it. So this is the data set using which we'll be training all the algorithms to predict heart disease. And these are the parameters based on which heart disease will be predicted. This is age, sex, which is gender, chest pain type, testing blood pressure, cholesterol, fasting blood sugar, rest ECG, maximum heart rate, exercise angina, old peak, ST slope, and the last column is target variable, in which 0 represents there is no heart disease and 1 represents there is risk for heart disease. So here in the first case, the person has no heart disease, and in the second case, the person has heart disease where target variable is 1. So we'll be using this data to train all the algorithms built in the project. So now close this, get back. Here in the second folder, we have the other data set of heart disease. So these are the parameters in the other data set. The first one is age. The next one is gender. Moving on, it is heart rate, systolic blood pressure, diastolic blood pressure, blood sugar levels, CKMB, troponin, and the last column is the target column. Here we have two cases, one is negative and positive. Negative means there is heart disease, that means there is risk of heart disease, and positive means there is no risk of heart disease. So now close this. We'll be using this data to train all the algorithms. So get back. Here we have two sample folders. In the first sample folder, which is DF1, we have heart disease of Cleveland and Hungary. So these are the test cases using which we'll be detecting heart disease in the front end. So now close this. Similarly, we have in sample DF2, which is the medical data sets sample. So we'll be using all these test cases for predicting the heart disease. So now close this. Moving on to the static folder. This folder contains files related to project styling and interactivity. They are CSS, JavaScript, and Bootstrap files. These resources are crucial for enhancing the visual appeal and functionality of the project's requirements. And this is the templates folder. Here lies all the HTML pages utilized in the project. They are index.html and about.html. Each HTML file represents a different page of the website and provides the structure, layout for displaying the content to the users. And this is the app.py file. This is Python file which encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. These are the two model files which contain the algorithm information, and that will be loaded into the project code during runtime. These are the two IPYNB files, which are the Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. And the last file is the signup.db file. This file is a database file, which is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. So using the command cd followed by the space, we need to paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folders path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and check for syntax errors or logical issues. So after running app.py file, Flask framework will host the application locally at the default address, which is localhost and the port unless configured differently. So now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. This python space app.py command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we need to sign up. So click on sign up and enter all the registration details if we are signing up newly. I have already signed up and have an account in it, so I'll directly sign in. So click on sign in. Here we need to provide username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. I already told you that we'll be doing prediction for both the data sets that are DF1 as well as DF2, which means they're both different types of heart disease data sets as we have trained all the algorithms separately. So first we will do prediction for DF1. So here we can see the parameters which are need to be entered. So based on the entered parameters, we will get the prediction whether there is heart disease risk or not. So the first one is age, which is the age of the person, and the next one is sex, which is the gender of the person. Moving on to the next parameter, which is chest pain type. It is the type of the chest pain experienced by the individual, which can provide insights into the potential heart issues. The next one is resting blood pressure. It is the blood pressure of the individual when they are at rest, and it is another crucial indicator of heart health. The next one is cholesterol. It is the level of the cholesterol in the blood which is associated with the risk of developing heart disease. The next one is fasting blood sugar. It is the level of blood sugar after fasting which indicate diabetes, a risk factor for heart disease. The next one is resting ECG, which is resting electrocardiographic results. The results of an electrocardiogram taken at rest providing information about heart rhythm and potential abnormalities. So the next one is maximum heart rate achieved. It is the highest heart rate achieved during exercise. So the next one is exercise angina, which is exercise induced angina. It is whether the individual experiences angina, that is chest pain, during exercise, which can signal coronary artery disease. The next one is old peak. Old peak, it is the ST depression induced by exercise relative to rest. It changes the ST segment of an electrocardiogram during exercise, which indicate the heart disease. The next one is ST slope. It is the slope of ST segment during peak exercise, providing further information about heart function and potential schema. So now we will enter them. So we will try predicting using the first test case. So the age of the person is 76, gender is one which is his male, and the heart rate is 73. Systolic blood pressure is 114, which is 114, and diastolic blood pressure is 68. Blood sugar level is 144. CKMB is 297.5. Troponin is 0.024. So now click on predict. So based on the entered parameters, we got the prediction as there is huge risk of heart disease for the patient, and it has correctly predicted. So now we will enter other test case. So under prediction, click on DF2 again. So here we'll be using the second test case. Here the age of the person is 30, gender is female, heart rate is 68, systolic blood pressure is 91, diastolic blood pressure is 61, blood sugar is 93, CKMB is 3.93, troponin is 0.003. Now click on predict. Here, based on the entered parameters, it has correctly predicted as there is no risk of heart disease for the patient. So in test cases also we have the same, which is 0, there is no heart risk. And here also it has predicted the same. Now we'll try entering other test case. So we'll be using this test case. So under prediction, click on DF2. So the age of the person is 29, gender is male, heart rate is 81, systolic blood pressure is 150, diastolic blood pressure is 51, blood glucose level is 100, CKMB is 6.48, troponin is 0.003. Now click on predict. So here also we can observe that it has correctly predicted that there is huge risk of the heart disease for the patient. So now we will enter other set of parameters for the same data set. Now we will use this test case. So the age of the person is 50, gender is male, heart rate is 64, systolic blood pressure is 110, diastolic blood pressure is 58, blood sugar is 90, CKMB is 0.994, and the troponin value is 0.864. So now click on predict. So based on the given parameters, it has predicted as there is huge risk of heart disease for the patient. So in this page is by entering the parameters, we'll get the prediction whether there is heart disease risk or not. Now we will see the graphs of the project. So we will see for the first data set, which is DF1. The first graph which we have is sample outcome graph, which shows the distribution of all the classes in the data set. Here on the x-axis, we have class labels which are 0 and 1, and on y-axis, we have the count of each class label. Here, 1, which is in red color, it represents the count of all the heart disease cases, and 0, which is in green color, it represents no heart disease cases. So from the graph, you can observe that there are more heart disease cases. And moving on to the next graph, which is correlation matrix. This shows the representation between variables, relationship between variables. So this is accuracy comparison graph, where on x-axis we have accuracy score of each algorithm, and on y-axis we have algorithm names. Similarly, we have precision score comparison graph, recall, FN score, AUC graph, Cohen-Kappa score graph. So now we will see the graph of the next data set. So under graph, click on DF2. This is the sample outcome graph in the second data set. This is correlation matrix. Here we have accuracy comparison graph, precision comparison graph, recall, FN score, AUC, and Cohen-Kappa score. So now click on sign out. By successfully developing robust system for predicting heart disease risk through advanced machine learning techniques like ensemble methods and meticulous optimization, we have successfully created a reliable tool for healthcare professionals. With the integration of Flask and SQLite, our solution is ready to make a real impact in healthcare.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.